Okay, this is a follow-up video to the Lewis dot diagrams video that I did a little while ago. And this is going to be Lewis dot diagrams that have more than two elements into them. So like CO2 is going to have, well, it has two elements but more than three atoms. So the three atoms there are going to make us have a more advanced Lewis dot diagram, meaning that we're going to need to do some calculations. The first thing that you want to do when you do this type of Lewis dot diagram is you put the least electronegative atom in the middle. In other words, the elements that are closest to fluorine are the most electronegative. So the least electronegative in this case would be carbon. So carbon will go in the middle, and then I'm going to surround it with my oxygens. If I had a couple more oxygens, they would go on the top and on the bottom on each of the bonding regions. And then I need to do some math. So I'm going to add up the total number of valence electrons for all of my atoms. So in this problem, oxygen is going to bring 6 electrons to the table. And there are 2 oxygens, which will give me a total of 12 electrons. Carbon is going to bring 4 valence electrons. 1 oxygen gives me 4. So then the total number of valence electrons that we'll have here is 16 valence electrons. Those 16 electrons are going to be given out to our atoms. And before I give them out, the third thing I need to do is to subtract the electrons that are represented by these bonds. So each bond is going to represent 2 electrons, so 2 and 4. I'll subtract those 4 that are in bonds, and that will leave me with 12 electrons to give out. And as you can see, number 4, I'm going to give my electrons to the most electronegative element first. In other words, the ones that are closest to fluorine. And I'm going to give those electrons out until I run out or until the oxygens are full. So 2, 4, 6, 8, 10, 12. Okay, so once I have my 12 electrons given out, I'll subtract those 12 that I just gave to oxygen, which leaves me with no more electrons. And then I need to do step 5, which is to check and make sure that all of my atoms are happy, that they're all touching 8 electrons. If you look here, we have 2, 4, 6, and then this line represents the other 2, which makes 8. So this oxygen would be happy. Then over here I have 2, 4, 6, 8, another happy element. And then I have 2, 4. So carbon is not very happy right now because it does not have 8 valence electrons. So what I'm going to do is I'm going to move some electrons over. So basically carbon pitches a fit and it throws this little temper tantrum, and eventually one of the oxygens will say, okay, just be quiet already, take my electrons so you'll be quiet. And so those electrons are going to move and form a bond. And if we rewrite that, it will be carbon in the middle with a double bond. The oxygen that before had 3 lone pairs will now only have 2. So it will look like this. And then over here I'll have my other oxygen. So this oxygen still has 2, 4, 6, 8 valence electrons that it's touching, but carbon still not so much happy. Carbon's now touching 6, but it wants to be touching 8 electrons. So what I'm going to do is one more time, carbon's going to pitch a fit, and those electrons will move over and form another double bond. So your final answer for your Lewis dot diagram here, whoops, start over down here. It's carbon in the middle, double bonds on each side, and then those oxygen atoms. You will notice that I did not split them up, the lone pairs. If they were together when I started bonding, then I'm going to leave them together when I finish. And we will do a few more examples. The next one we will try is NF3. So nitrogen is less electronegative than fluorine, obviously, because fluorine is the most electronegative element on the periodic table. So I'll put my fluorines surrounding it. Then I'm going to do my math. So nitrogen brings 5 valence electrons to the table. Fluorine will bring 7. And there are 3 fluorines. So that gives me a total of 21 valence electrons for fluorine and 5 for nitrogen. I'm going to add those together to give me my 26 valence electrons. And those 26 are going to be what I start to bond with. So I need to subtract the electrons that I put into bonds. I have 2, 4, and 6. So I'll subtract those 6, which gives me 20 electrons left to give away. Those 20 electrons are going to go to the most electronegative element first, which would be fluorine. And I'll spread them out as I go. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So I just gave away 18 to fluorine, which leaves me with 2 more left to go. And then those 2 elements are going, 2 electrons are going to go on nitrogen. And that will satisfy nitrogen. And I have done all of my math, and I'm good to go. So go ahead and give SO2 a try. When you start this one, you will have sulfur in the middle because sulfur is less electronegative than oxygen. And then you will put the oxygens around outside that sulfur. Then we're going to start doing our math. So you will have 6 valence electrons that come from sulfur, and oxygen will bring 6 as well. Of course, there are 2 oxygens, so I'll multiply that by 2, which gives me 18 total valence electrons. And then I'm going to start subtracting. So I'll have the 18, and I'm going to subtract the 2 bonds. So that's 2 electrons and 4 electrons. 14 electrons left to give away. And I'm going to give them to the most electronegative element first. So that'd be oxygen. 2, 4, 6. You'll notice I'm spreading out as I go. There's 12. So I gave 12 of them to oxygen, which leaves me 2 more. So those 2 will go to sulfur. And then you'll ask yourself, is everybody happy? And of course, sulfur right now is not. It's touching 2, 4, 6 electrons. So it needs 2 more. So just like earlier, sulfur is going to pitch a fit. And 2 of those electrons that are on sulfur are going to move and become part of not on sulfur, on oxygen. They are going to become part of a double bond. So I will have sulfur with its lone pair. Then I'll have a double bond with one of the oxygens. You get to pick which one. And then I'll have a single bond with the oxygen that's over here. Okay, and that's it. One more example is Cn with -1 charge, also known as cyanide. And what you're going to do here is you're just going to line them up. And the reason we can't just draw Lewis dot diagrams here is because of this -1. So remember that -1 means you have an extra electron. So when we do our math, that will come into play. Carbon has 4 valence electrons because it's in group 14. Nitrogen has 5. So that gives me, if I add them up, 9 valence electrons. But because I have this -1 charge, I have to add an extra electron, which will give me 10 electrons to give away. First thing I'm going to do is subtract the 2 that are in that bond that I just drew, which leaves me with 8. I will give them to nitrogen first, so 2, 4, and 6. And then that leaves me with 2. Those 2 will go to carbon, and then I'm finished. Or am I? Carbon is not happy here. Carbon only has 4 electrons. So, just like it did earlier, carbon's going to throw a fit. And nitrogen is going to beg it to quit crying by moving over 2 of its electrons. So now carbon would be touching 2, 4, and 6. Still not happy. So I'll move over 2 more. And there's my 8. So when I go to draw this, I'm going to have a triple bond between carbon and nitrogen. So there's my final drawing. One more thing I want to mention is up here, you have a resonance structure. So because I chose this oxygen to move over its electrons, I picked something. And when you pick in chemistry, there's always other options. So those other options form what's called resonance structures. So if you did this problem, the reverse would be correct as well. So instead of this oxygen giving off its electron, it could have been this oxygen over here. So our double bond would be on the other side. So if your teacher asks you to draw resonance structures, then either one of these would be correct, and they're probably asking for both. In my chemistry class, if I ask you to do a problem like this one, and you have to make a choice somewhere along the way, if you give me both of the resonance structures, I'll give you extra credit. And that's it for Lewis dot diagrams.